Hi, today we are going to learn about hypothesis as a beginning to the course of machine learning. So, hypothesis, the meaning of the term is that it is a supposition or an explanation made on the basis of limited evidence as a starting point for further investigation. In our daily course of life, we'll be having many hypotheses. Suppose somebody is suffering with cough. We immediately say that person might have wet in rain. That is our hypothesis. That may be true or that may not be true. So it is something like an explanation. Further, if you see the similar terms, then you will understand. In our real life, we may make some statements that some ice creams are good. That is an hypothesis. Now here, it is not a simple statement, but here notice the term, on the basis of some evidence. We propose an hypothesis. Now, let us go mathematically that we have a values of let us say we have a values of x and y or x and function of x. Let us say this is x value so I may be having x value and a function of x, that means y. So I may have this data. Suppose x is equal to 0, the y value is 2. When it is 1, it is 4. It is 2. Y value is 6. And when it is 3, y value is 8. When it is 4, the y value is 10. So this is the data. This is the data. So now my point is how we got y from the x. We want some explanation for that. What might be, now we are given with input values. See carefully, we are given with the input values here and we got output values, and the concept is y is f of x, where x is the input and y is the output. So what is this function that approximates the relation between input values and output values? There may be many hypotheses. So for example, I may assume by seeing the first example, I may propose something like this. Sorry for that. So I may propose, by seeing the first example, I may propose y is equal to x plus 2. That is true, that is an hypothesis. Let me say h0 or h1, small h1. That is true for the first example, when x is equal to 0, y is equal to 2. But when you come to the second example, the value according to this hypothesis is 1 plus 2, 3, 2 plus 2, 4, 3 plus 2, 5. So this hypothesis is true only for the first example. Now seeing the second example, I can propose another hypothesis, y is equal to x plus 3, 1 plus 3, 4. Maybe we can call that as h2. That is true only for the example 2. Seeing at example 3, I may propose x plus 4, that is h3. That is only true for example 3. For the next example, I may propose x plus 5. That is only true for the fourth example. And another hypothesis is x plus 6, which is h5, which is true only for 5. So this h1, h2, h3, h4 up to h5 is a set of hypotheses indicated by capital H. I can propose still more hypotheses. For example, let us say if you see this example, I can propose y is equal to 3 into x by seeing that example. That is true only for training example number 3. That it may be h6. Then h7, I may propose if I see this, I may propose y is equal to 2 into x plus 2. Actually, I generated that data from this equation. So this hypothesis H7 satisfies all the examples. If you substitute 0, it is 2 into 0 plus 2, 2. This is satisfied. If you substitute 1, 2 into 1 plus 2, 2 plus 2, that is 4. This is satisfied. So 2, if you substitute 2, 2 2s are 4 plus 2, 6. It is satisfied. 2 into 3, 6 plus 2, 8. 2 into 4, 8 plus 2, 10. So my seventh hypothesis satisfies all the evidences, given evidence. So my problem in machine learning is, out of the set of all hypotheses, I want to search for the hypothesis which will satisfy the given all the examples, so that because it is satisfying examples from 1, 2, 3, 4, 5, I also assume that it will be true for the sixth example. Because this is mathematical equation, I could propose an equation. But if you take the concept like whether a person is having COVID or not, if a person is having cancer or not, if a given shape, given picture, it belongs to dog or cat, this type of concepts are not as simple as we have taken this hypothesis. So here we have to see that hypothesis is a model that approximates a target function, mapping inputs to outputs. So this is called a function approximating. We are formulating the relation between the y, the x and the y based on the given examples. Now we have here 5 examples. At the same time, let us close this topic by defining what is inductive hypothesis. You know mathematical induction, that if given theorem, we start with a base case n is equal to 0. We prove that it is true for n is equal to 0. then we prove that it is true for n is equal to 1. Then we prove that if n is equal to k, that is true. And we prove that because if it is true for n is equal to k, it should also be true for n is equal to k plus 1. So because the hypothesis that y is equal to 2x plus 2 is true for given 5 examples, which we call a training examples, so we hold that this hypothesis will also be true for other given examples. So in the next lecture, we are going to see how we can find that hypothesis. So hypothesis is a searching problem. In other words, proposing an hypothesis is also called concept search or concept learning. Concept learning. What we are doing in learning? In learning, we are searching for a hypothesis. We are searching for a hypothesis which will best fit for given data, that best fits the given data. So concept learning is a searching problem. It is a searching problem. What we are searching? We have a set of hypotheses, H1 to so on Hn. Among this, which will satisfy all the given training examples. So I hope hypothesis concept is clear. What is hypothesis? An explanation based on the limited or given evidence.